Hello everyone, I'm going to explain to you the game I've created called Hexpel. So, once you are inside the game, you will see the main board of the game with all the pawns on top. You will see two buttons, one on the left button side, one on the right button side, that allow you to go back to the menu on the right and activate and deactivate the AI on the left. I'll explain this a bit later. And you also have a UI on the top left that shows exactly how many pawns each player has left, and also with a small brown line is going to indicate whose turn it is. Now, how do you play? You can click on either the red pawn or the blue pawn. Both of them are magnets, and you're going to, once you click on one of them, you are going to be able to select where you want to move it. The red pawn is going to be the repel magnet that is going to move pawns next to it away, one tile away, and you have the blue pawns that is the attract magnet that is going to take pawns that are two tiles away, one closer. When they do that, they're going to create some movements, and sometimes pawns are going to move onto other pawns. According to the rules, some different things can happen. If a pawn moves onto another pawn of the same color, they just stack together. But if they move onto a pawn from a different color, an attack happens. And in that case, the attacker always has the advantage. So if the attacker has the same or more pawns as the defender, the attacker wins and destroys all the defender pawns. If the attacker has less pawns than the defender, all the attacker pawns are destroyed and the same amount belonging to the defender is going to be destroyed. The objective is to destroy all the pawns from the enemy. Now, let's explain the coding that I did. First is the core of the game. The core of the game is going to be basically an array of arrays. So in this case specifically, for example, you have a 7x7 array that has numbers. When you start the game, it's going to be numbers between -1 and 1, but it can be any number between -15 and 15 because you only have 15 possible pawns. The idea is that each number inside an array, inside the array, is going to be a position on the board, and the number is going to be the value of that tile set. So each tile is going to have a value, and the value, if it's a positive value, it's going to be a black pawn, and if it's a negative value, it's going to be a white pawn. So for example, if you have on a tile +2, that means on that tile you have 2 black pawns, so you will have the black pawn and a number 2 on top. And everything that is going to change the game is going to change it through there. That means if a magnet moves, it's going to change the values in that grid. When the grids change, then the pawns are going to update their color and the number according to the value of the grid. So basically the grid is the centerpiece of the game, and everything else changes the grid or changes according to the grid. There are some exceptions to this, but this is the main core of the game. Okay? Then, going to the game creation, what we have is basically a game initializer that is going to create that array and create some starting positions. And then we have the game creation, which is going to actually do the job. So what we have is a few prefabs, and it's going to generate all those prefabs in the selected places that we want. So we're going to create all the tiles, all the borders, we're going to create the pawns, which some of them are going to be invisible unless the value of the grid is different than 0. We're going to create the pawn values, which are the numbers that are going to be invisible unless there are more than one pawn on a specific tile. We're going to create the repel pawn and the attract pawn. And then we are also for each of them, we're going to set some variables. So for example, the position in the magnets or the type of magnet, those are going to be set in this game creation mode. Once everything is created, the magnet script is going to take over so that you can actually play the game by clicking on the magnet, clicking on a target to move the magnet, and then the magnet is going to automatically apply its effect around it by changing the numbers on the grid. Okay, so that's the main core of the game and the creation. Now, let's go to the AI that I created. It's a very, very simple AI that only looks at one move ahead. So basically, just decided what is the best move that I can do now. and the values that I have for its behavior are not set in stone because I've been in the last 2 days doing some testing and they could be refined. However, the AI works as I want it to work. The only thing is to make it smarter, so to speak. So, what do we have? We basically have first, we create a move list, which is going to be all the allowed moves that the AI can make. Once you have the allowed moves that the AI can make, we're going to go through all the moves and decide how good the move is. So, for example, on the central tile, you can place the repel magnet, and that is going to have a value of 5, for example. And if on the same tile you place the attract magnet instead, you will have a value of -3. So from those two, clearly the value of 5 is way better. So that's what it's going to do. It's going to check every possible move with both magnets and only keep the best moves. And once it has all the best move, it's going to create a list of best move. It's going to select one at random, and then it's just going to apply the movement. So it's going to change the magnet that it wants to change, repel or attack, change the position so that they change what is happening around them, apply their effect, and so that the player after that can actually play. Now the values are going to be different according to repel or attract. Basically the only difference is like in what direction the attacks are going to be made, but you have basically the addition of the 6 moves that one magnet creates, and then each attack is going to be calculated independently in the function called attack value. There we go. So in attack value, if the move is legal, it's going to go through all the options, and I know this is not the most compact way to do it, but I wanted to make sure that I could tweak every single number separately just in case I saw a weird behavior in the AI. So we have basically that joining your pawns together is a very good move. Joining the ones from the opponent is a bad move, so we give them positive and negative values according to what we want. So positive is good, negative bad. So for example, if the pawn that is moving is yours, and yours from the AI, and the pawn that you are attacking is from the player, then it's going to be a good move because you can destroy these pawns. On the other side, if it's one from the player that is moving onto one of the AI is going to say, oh no, that's not that good because it's going to destroy my pawns too. And then if it does just useless moves, that's going to be usually bad, or just neutral. So that's the idea basically. And what it does is basically once the player finishes its turn, the magnet is going to change the value of next turn to on, and then next turn what it's going to do is in the updates of the game script, you have a function that is called end turn that is only going to activate if the next turn is supposed to be on and there is no movement in progress. This is to avoid 2 turns overlapping. So basically we have 2 different bulls so that you can activate one and deactivate one whenever you need them so that they don't mix together. So as soon as the next turn should be happening and the movement ends, we are going to finish the turn. And finishing the turn is going to depend on if we have PvP on or not. If we have PvP on, it's only going to check if the game has ended, and it's going to change the turn indicator to make sure which player has to move, and that's it. It's basically going to finish and let the next player play. However, if we are playing against a computer, it's going to do exactly the same thing, but then it's going to ask the AI to make a move. The AI script is going to make its move, and then it comes back to the end turn function, and then it's going to finish the turn at that point. So that's how the game basically works.